Hello, this is Mr. Flatness, and today we're going to be estimating quotients. We're also going to be looking at our estimates and judging to see if our answer is reasonable. There's one vocabulary word that I would like you to put down in your notebooks right now, and that is compatible numbers. And also to write down its definition as well. Compatible numbers are numbers that are easy to divide mentally. I like to think of them as basic fact numbers. So some examples that I'd like to show you are numbers like this. 24 divided by 3, 16 divided by 4. These are compatible numbers because when we divide them, we can get whole number answers. So 24 divided by 3 would be 8. 16 divided by 4 is 4. Non-example numbers would be numbers like this, 36 divided by 7, or 28 divided by 14.3. These are not compatible numbers, as you will not get a whole number when you divide them. Also in your notes, please write down the examples of compatible numbers and non-example. So as I said earlier, our skill for today is estimating quotients, and so in order to do that we're going to use rounding again to create numbers that are compatible. If you look at our first example, 8.75 divided by 3, we can tell that that is not an example of compatible numbers, as we will not get a whole number that goes quickly as a quotient. So rather we're going to use rounding. So when I take a look at the two numbers 3 and I look at 8.75, I first noticed the 3, a whole number, it's single digit, and so there's a lot of 3 facts that I know. And the biggest 3 fact, or the quickest 3 fact that comes to mind is 3 times 3 is 9. And then I noticed that 9 is very close to 8.75. So what I will do is round 8.75 to 9 and then divide that by 3. Now I'm working with compatible numbers that are very easy to divide in my head. So 9 divided by 3 is 3. In example 2, we have 49.3 divided by 7. Again, notice that I have one single digit number, 7, that I should know all kinds of basic facts of. And so again, the basic fact that comes to mind for me is 7 times 7 is 49. Well, 49 is very close to 49.3. So I will round 49.3 to 49 and divide that and keep the second number 7 the same. And 49 divided by 7 is 7. So I take numbers that are not compatible in the two examples and turn them into numbers that are compatible, so I can generate quotients that are easy to do in my head. Let's have you try one. Let's go 57.4 divided by 8. Press pause right now and figure out your answer. Then press play to get the answer to see if you were correct. So looking at 57.4 divided by 8, I know 8 times 7 is 56, so I'm going to go 56 divided by 8 equals 7. So there are my compatible numbers, and 7 would be my quotient. In this next slide, we have a couple of different examples. This time you'll notice in 32 divided by 3.9, 32 is a number that is a whole number, not a decimal. And then 3.9 is the decimal, so we've changed it. Notice our slide title is Estimate by Rounding Divisors. Okay, so we should probably review back and talk about what is a divisor, what is a quotient, and what is a dividend. So taking a look at these numbers, I can go through and talk about just a division problem. In a division problem like this, the first number that we see is called the dividend, and that's what we rounded in the first 3 examples, the dividend. The second number is called the divisor, and the divisor is always the number you are dividing by. And then the answer is called the quotient. Okay, so press pause right now and write down and identify what numbers are the dividend, the divisor, and the quotient. Okay, so I'm going to erase those vocab words again, and I'm going to take a look at the problem at hand. So 32 divided by 3.9. I'm looking at 32 and 3.9, and I think to myself, well, I know that 32 divided by 4 would give me a whole number. So I'm going to change and keep 32 the same, but I'm going to round 3.9 to 4, because I know that 8 times 4 is 32, therefore 32 divided by 4 would be 8. So I took numbers that were not compatible, didn't really work well together, and make them into compatible by rounding. And so 4 we know is very, very close to 3.9. So my estimate 8 is very close to the real answer. Why don't you try the next one? Press pause right now. Try the next one on your own, and then press play and see if your answer is correct. So I take a look at 99 and 10.75. And what comes to mind right now is 99. And I know that 11 times 9 is 99. So therefore I'm going to create and leave 99 by itself and divide it by 11, because 10.75 is very, very close to 11. It rounds up to 11. So 99 divided by 11 is 9. Again, notice how this all generates around basic facts. When you take a look at the first one, we had 8. 8 times 4 would give me 32. 11 times 9 is 99. So I'm using my knowledge and memory about my basic facts to help me create these answers for compatible numbers. Let's try one more. I'm going to take 144, and I want you to divide that by 13.1. Press pause. Come up with two compatible numbers to divide, and then give me an estimated answer. So looking at the 144, that I know that's a basic fact, because I know that 12 times 12 is 144. So I'm going to rewrite my problem as 144 divided by 12 equals 12. So that's going to be my estimate. Notice in this example I actually rounded down. 13 I went down to 12. And that's okay. You can round down or up, even though the rules of rounding say that 13 doesn't round down to 12. Estimation and common sense says that you can use 12 because 12 is close to 13. So my answer of 12 would be very, very close as an exact answer. Here's an example of when you would use estimation in the real world. The average weight of a panther is 64.2 kilograms, and the average weight of a coyote is 14.8 kilograms. About how many times heavier is the panther? Explain why your answer is reasonable using compatible numbers. The first thing I do is take a look at important information: the weight of the panther, the weight of the coyote, and then I see this word about, okay, which means that tells me I'm going to estimate. I don't care about an exact answer, I just want to be close. And then how many times heavier? Okay, how many times heavier are three words that kind of imply that they want a division sentence here. So I want to take 64.2 and divide that by 14.8. This problem is a little more difficult as we're getting away from some basic fact information. I do know the number 64. When I look at that number, I could round 64.2 down to 64. And then I kind of take a look at some other things. One thing I notice about 64 is that it's even. And so I know that even numbers have a possibility of being factors of 64. For sure, 64 can be cut in half, which is 64 divided by 2. But also I know that 64 divided by 4, we can cut that in half twice. 14.8, when I look at it, okay, that is close to 16. and 64 divided by 16 is 4. And that's kind of a basic fact I've worked with and known about, which 4 would be very, very close. Another way to go about it, if you didn't have the 16 fact down, is you could take 64, change it to 60, and then take 14 and create the number 12. 60 divided by 12 is a basic fact that we should be able to work with as a 6th grader, and we should know 12 times 5 is 60. So notice between 4 and 5, it isn't a whole lot of difference. Either answer would be good. Again, all we are wanting to do here is estimate. So I would be fine, and this answer here, 60 divided by 12, as your compatible numbers, would be close enough to the actual problem of 64.2 divided by 14.8. The final question we have is dealing with reasoning, and so a question that is stated on this slide: is 10 a reasonable estimate for 83.6 divided by 7? So thinking back, again, one thing you should notice right away, we have 7 here. It's a whole number. And so I should be thinking about all my 7's facts, 7 times 1 all the way through at least 7 times 12. So when you think about all those facts, one fact that comes to mind is I know that 7 times 12 is equal to 84. Well, 84 is very, very close to 83. So the compatible number division sentence would be change 83.6 to 84, rounded up, divide that by 7, and know that your answer then would be 12. Now, they came up with 10 as an answer. Here's a question: is 10 a reasonable estimate? And I would say, yeah, we could probably say 10 is reasonable because 10 is fairly close to 12. But if you had to pick which answer is closer to the actual answer, I would choose this one right here, as I did not round very much. I only rounded the 83.6 and I changed it to 84. So very, very little rounding was involved in this particular problem. So my answer of 12 is going to be a lot closer than 10, even though they are both fairly close. So actually you could argue both. You could argue that 10 is reasonable because 10 and 12 are fairly close to each other. But you could also argue that 10 is really not a reasonable estimate because we could get a lot closer with 12. So in conclusion, in working with estimating quotients, the biggest skill that you need to use is your knowledge and memory of basic facts, 0 times 0 all the way up through 12 times 12, so that you can generate compatible numbers to work with so that your estimates are close. And that way you can justify whether or not your estimate is close enough to the actual answer.